All right, howdy, howdy. My name's Catherine Lewis, and today I'm going to be talking about welding. So, just a little bit about the basics. Welding with the exclusion of oxyacetylene is done using an electrical arc, and this is basically essentially creating a short circuit where you have one terminal being the base metal and the other terminal being the electrode, which is what the welder holds. And whether the electrode is going to be positive or negative depends on what welding process you're doing. We'll get a little bit into that in a moment. It requires flux or gas shielding, the primary purpose of which is to prevent oxidation and water vapors from pulling or from polluting the weld. And flux also helps float additional impurities out of the metal, but that's not necessarily true for gas shielding. But the primary thing that you're trying to avoid is oxidation. Without some type of protection, the weld will be considerably less strong, where it is unusable. It might not fall apart right there, but any amount of load, it's not going to be able to sustain what you need it to. So the difference between brazing and welding, brazing, also soldering. I mean, soldering and brazing are a little bit different depending on the temperatures, but those two are separate from welding because if only the filler metal reaches melting temperature, it would fall under the category of brazing or soldering. And to be considered welding, the base or parent metal also has to melt. So just a little bit more on the basics. Electrode positive essentially means that the part that the welder holds is positively charged and the base metal is negative. This gets the electrode hot. And this is something that you'll have for the ones where you are consuming the electrode. This will make a little bit more sense when we go on and explain the specific types of welding. But essentially, if you have an electrode that you're using up, like in stick or MIG welding, then electrode positive makes more sense for what you're doing. And electrode negative means that you have the electrons flowing from the electrode to the base metal, and it's actually going to get your workpiece hotter, your base metal hotter. AC, which is really only used in aluminum welding, or primarily used in aluminum welding, is going to switch between those two for positive and negative. So there's four main types of welding, at least the non-robotic welding that we're going to be talking about. And that's GMA, MIG. Basically, the parentheses is what they're more commonly called. So MIG, flux core, TIG, and stick welding are what we'll talk about here. So GMA is gas metal arc welding, and this is the one that we also call MIG, which is metal inert gas. It uses a consumable metal electrode with shielding gas surrounding it to flush the workpiece, and this is that protection that we were talking about. You can see in the diagram here, that this is the nozzle where the gas comes out, but it's also in the center of it is where you have your consumable electrode, and that's being fed through a spool, or there's a spool of wire being fed through the gun. For aluminum, because it's a softer metal, you're going to have the spool very close to the nozzle because you can't feed that much without it kinking, but for steel, it's usually going to be back with the welder. So yeah, there's gas shielding. This one's great because it's easy and it's fast, and you can whip together projects a lot quicker than with, for example, TIG welding. And yeah, it's typically DC positive. This is the one that people might give MIG welders a hard time because they say that it's the easiest type, like it's using a hot glue gun, but there is definitely some technique that you need to do it, especially if it's out of position, which is anything that's where you're welding and you're not sitting with a flat piece of metal in front of you. So if you're doing vertical welding or whatever, there's more technique in that. Flux core arc welding is very similar to MIG. It's essentially, instead of the gas, you have a protective flux integrated into the wire itself, so that gas is not necessary, but it can be used in conjunction with gas shielding, and this is something that you do with, it's something that would be used maybe in like a harsher environment, like if you're outside on a rig or something and it's windy, and you have both those layers of protection to help your weld come out as pure, as not contaminated as possible. So also fast, but the flux core arc welding takes more skill than MIG does on its own. It's really hot, and it does have high spatter comparative to just MIG itself. Okay, this one, it says GTOG, gas metal arc welding, gas tungsten arc welding, that's a typo there. But this one's more typically called TIG. And this is the only one we'll be talking about today where the electrode is not your consumable piece. You have an electrode that's made of tungsten because it can handle really high temperatures without melting. And then you have an external filler rod that you yourself are feeding into the workpiece. But it still uses that DC circuit where you are getting the piece really hot with your electrode completing the circuit and your base metal being the side that it's arcing over to. So this one's much slower than the previous two processes. It takes a lot more time. It also, depending, but it can put more heat into the piece because of time. And in stainless and stuff, I mean, stainless is a great example of when you'd use this, but you do have to learn some special techniques because it warps easily, and putting more heat into the piece you just have to accommodate for that. That being said, this one is also one of the strongest when done correctly because of having fewer impurities compared to other processes, and you also have a lot of control compared to the other processes. This one can be DC positive, negative, or AC, depending. Like aluminum is going to be using AC, and then you can use DC positive or negative depending on what you're doing, but for steel. Shielded metal arc welding, more typically called stick welding, is one of the oldest aside from oxyacetylene. This is the one that if you have like a farm welder, it's probably going to be a stick welder. It is a difficult one to master, but it is incredibly useful. It has high spatter, so this is the gentleman in this photo isn't wearing one, but if you see welders with bandanas, there's a good chance they're doing stick welding or flux core. It can be really fast if you're good at it, and it's often used for structural work or repair. This is just a honorable mention because it's such a cool practice. Underwater welding. This statistic does vary a lot from source to source, but some say that it's has a mortality rate as high as 15%, and that was as of 2014. So it still has an incredibly high mortality rate, and despite that, the average salary of an underwater welder is $54,000. 54K. So it's a hard job. It's a really, really cool job. But yeah, just thought that was one that was worth mentioning. This might seem like a lot of information to take in. You really only need the basics to get started, though, and then it's really just, like, you need to know the safety basics, how to not hurt yourself, and then it's just practice, practice, practice. It is really fun and rewarding to build something from nothing, and it's useful to know for repairing things. There's also enough diversity in the types of welding that you might find that you do really like one, even if you don't like the other. So for example, TIG is much more delicate. There's very little spatter. It requires patience that a lot of welders don't have. So that's one that I've been told that women are more drawn to, but it really is just like whatever your interests are, you can find something that'll work for you. So it's definitely worth at least trying out the trade. And then here's where I would typically ask questions, but we can't do that now with current circumstances, so that should be it. Thanks.